All right, ladies and gentlemen, welcome to IC Taiwan Grand Challenge Unveil. My name is Helen and I'm your host for this session. But before we start, we have an introduction video for everyone to enjoy and has a brief knowledge about our event. So without further ado, ladies and gentlemen, let's enjoy our VCR, please.
Before we muster the courage to take the first step, no one imagined we could go so far. We found answers in this small flint. Before enlightenment, no one knew the flint would ignite the hope of human civilization. Let us no longer fear when facing the capriciousness of nature. Let us endure the test of life. We are determined to push beyond the limits of physics, to shatter all ingrained perceptions. Taiwan, the island of semiconductors, we would not hold back. Gather all our strengths to empower each other. Together, we stride towards the future of semiconductors. We respond to the trust given by every international partner. Here resonates the truths and inclusivity we earnestly seek, pursuing sustainable development across generations, guarding love and freedom with justice, creating miracles with a spark of inspiration, persisting in faith, seeking another kind of harmony. The future lies in your hands. We stand here, continuing this blueprint of a brilliant future. IC Taiwan, IC Grand Challenge.
IC Taiwan, can we have a big round of applause to kickstart this event? 先一个掌声，我们一起揭开这个活动的序幕。Right, good afternoon. Our Vice Minister of National Science and Technology Council, Mr. Su Zhengang, and Ms. Andrea Shi, the Director General of Department of Academia, Industrial Collaboration and Science Park Affairs, and Mr. Conrad Yang, the Chief Organizer of IC Taiwan Grand Challenge, and of course, welcome all of our jury, and the distinguished guests, the winning teams, and of course, our participants online as well. Welcome to IC Taiwan Grand Challenge Unveil. My name is Helen, and I'm your host for this session. And as a brief introduction, the IC Taiwan Grand Challenge is an initiative started by the National Science and Technology Council in order to bolster the Taiwan IC startup ecosystem and, of course, to attract global talents and investments. And in the first stage of the IC Taiwan Grand Challenge, we have selected 6 outstanding teams from 50 countries and in a total of 72 technologies. So today we are very, very excited because we are going to meet them all on stage. But before we start, we would like to first welcome the Vice Minister of National Science and Technology Council, Mr. Su Zhengang, to come to the stage and give us opening remarks. 掌声欢迎苏副。
So, good afternoon, all our review committee member and our selected winning teams and all the distinguished guests. Ladies and gentlemen, good afternoon. It's my great pleasure to be here to join together with you to attending this IC Taiwan Challenge Unveil. As you may know, Taiwan already have a very well-established semiconductor industrial ecosystem here in Taiwan. So that's why we are here to see how can we make future technology and application here. So President Lai say, we want to develop Taiwan into an AI island. But how can we make it? As you may know, we have a very powerful manufacturing capacity here in Taiwan, especially in semiconductor. But we try to develop software as well. And the second, we want to make system integration for the semiconductor industry. And the most important is that every industry and every people can utilize the AI technology into their living and their working, so can increase their working value and increase their living quality. Today we are here to have 6 outstanding teams selected from 72 teams. They can share their technology information with us, and we can learn from them and let them have how can they integrate into our supply chain. So we are very eager to listen in their sharing their technology and experience. So we are very happy to have you here, and please enjoy here and see all the new technology. Maybe in the future they can have a very important impact to our living and our working. So on behalf of our Science and Technology Council, I cordially welcome you to here and wish you have a good living, and all our foreign delegation here have a good life and have a good stay here in Taiwan. Thank you very much. Thank you.
Thank you, Vice Minister, for this inspiring encouragement. But would you please remain on stage, because we would like to seize this opportunity and welcome our distinguished guest to come on stage and join the group photo shoot. So with the following order, so first please welcome Ms. Andrea Shi, the Director General of Department of Academia, Industry, Collaboration and Science Park Affairs. 我们掌声先欢迎国科会产学处的许增如处长。And then to follow, please welcome Mr. Conrad Yang, the Chief Organizer of IC Taiwan Grand Challenge. 我们欢迎 IC Taiwan Grand Challenge 杨光磊总召集人，欢迎。Next, let's welcome our jury. So first, please welcome Professor Winston Xu. 我们欢迎徐宏明评审老师，掌声欢迎。And then, let's welcome Ms. 李正怡评审老师. Our jury, please join us. Thank you. Next, let's welcome Mr. Victor Wu 吴义宏评审老师. Welcome. Thank you for joining us. Thank you. And then also, let's welcome Mr. Robert Jian 简明正评审老师. Welcome. And then, to follow, let's also welcome our winning teams, the representatives from our winning team. So first, let's welcome Quinus Technology representative. Welcome. Thank you for joining us. Next, let's welcome Newsight Imaging. Please join us for the group photo shoot. Thank you for joining us. To follow, let's welcome GalaVerse representative. Please, thank you for joining us. Next, let's welcome the representative from Ranictek. 掌声欢迎. Thank you for joining us. To follow, please welcome Polaris Electro-Optics. Welcome. Thank you for joining us. Finally, please welcome the representative of Voltraware. 掌声欢迎, please. Thank you so much for your contribution. Well done, everyone. Thank you. So, for the group photo shoot, we will take several group photo shoots. For the first one, please wear your smile and look at the camera in the front. Okay, when you're ready, on the count of 1, 2, 3. Perfect. So we have one more group photo shoot. Can we do the, thumb up gesture? Yes. Of course, very Taiwanese gesture. Okay, let's look at the camera on the count of 1, 2, 3. And we are not done yet, because we have prepared lovely play cards for everyone to hold. We have many different kinds of play cards with different slogans. So we can take this play card, hold the play card to your chest, and then have some more photos as well. Okay, nice. So it has very lovely slogan. Okay, so when you're ready, also wear your smile and look at the camera in the front on the count of 1, 2, 3. Nice. Can we have one more final group photo shoot? Also with play card and your thumbs up. Thank you. Yes. Okay, let's have one more. 3, 2, 1. Okay. Is everyone good with the photo? Okay, nice. Okay, ladies and gentlemen, let's give our Discord just a big round of applause. 我们掌声谢谢我们所有的参赛者以及评审老师以及贵宾们。Okay, so ladies and gentlemen, our VIP guests, you may return to your seat for a while. Thank you so much. And we are about to start our exciting presentation for everyone to enjoy. Thank you so much for your contribution and your participation. Thank you so much for your support. Okay, and also for your information, the IC Taiwan Grand Challenge is also open for startups, university teams, individuals who focus on IC design innovations, as well as GE-based innovative applications. And we will give special attention to applicants in smart data, in AI, and small mobility, small manufacturing, small medtech, and also sustainability. So the first team that we are going to welcome is under the category of smart data and AI. Okay, so the first team is from UK. The company name is Quinus Technology, and they will be talking about the revolutionary memory technology, ULTRARAM, which is a remarkable patent memory technology developed by Lancaster University. So now, without further ado, let's welcome the CEO, Mr. James Ashford-Pook, to the stage. 掌声欢迎, please welcome.
Hello, good afternoon, everyone. I'm James Ashford-Pook. I'm the CEO and co-founder of Quinus Technology. It's a huge pleasure to be here in Taiwan again this week, third time in the last year, in fact, and we're very honored and proud to be a recipient of this wonderful competition and award. So let me run you through a few minutes about us and our technology. So ULTRARAM was actually conceived in the University of Lancaster in the UK back about 6 years ago. We've been on a mission of R&D ever since then. We're still on that mission, of course. And we spun out the technology last year in 2023. So a bit about the problems and opportunities. Of course, today's world, everyone's striving for the green economy and saving power. And one of the key issues today with memories is finding low power for applications such as data centers. Also, Moore's law is obviously coming to an end, and we need to jump the memory wall and find new technologies for the future revolution of AI. The memory market is also huge. It's approaching $250 billion. Currently it's around about 160, and of course a very big market opportunity. The competition and the landscape today is pretty much dominated by Korea, South Korea and the US. But of course Taiwan has an important stake in memories as well, so we're very excited to be able to grow our business potentially here in Taiwan. A bit about the solution. So we've actually developed a universal memory, which is a combination of flash, which is non-volatile, of course, and DRAM. So we have a universal memory that's got the attributes of both methodologies in one. So the innovation is our secret sauce, if you like, is twofold. We use silicon wafers, but we grow compound semiconductors, the 3-5 materials, which you may have heard of, have been around for many years and used in things like RF and power electronics today. We're currently scaling up our technology into arrays and working with a big company in the UK called IQE, which is also here in Taiwan. So very good synergies between what we're doing in the UK and here in Taiwan. A little bit about our benchmarking. We have here, as you can see, a chart, and you can see our performance attributes are very advanced compared to the current offerings. So the switching energies, and in all dimensions we outperform the existing products. We also have very great parameters in terms of temperature range. We've done radiation hardness testing. Again, a universal memory with very strong attributes. Some of our market segments, we've been exploring space and defense for our sort of beachhead early customers, quantum computing, and the more exciting areas, of course, AI. We've just started to explore in-memory computing, which is very exciting as we're able to bring our memory arrays with their amazing attributes into that domain. We've done some initial benchmarking with some partners, and the results are very impressive based on some device-level modeling we've done in India. So already we're seeing potential performance above companies like NVIDIA and Google. So another great use case for ULTRARAM. The team today is still pretty small. It's a university spin-out, so we're looking for funding at the moment and hoping to grow significantly in 2025. We've had a huge range of accolades around the world. In the US, the Flash Memory Summit, which is a very prestigious award. And we've been very active here in Taiwan. As I said, this is actually my 4th visit in 18 months. As I said, we're looking for funding. We've been grant funded up to date by about $5 million. And we're looking to raise our first seed round by the end of this year. So in summary, we believe we've got a new memory technology which will jump the memory wall and give a leap forward in performance and design opportunity for the future of AI. I think I might, one more slide. These are some of our collaborators around the world. And this is our team up in the north of the UK in Lancaster. And I think there is a little video here I'll just finish on just to give you a bit more of a background of the technology. Thank you very much.
Introducing ULTRARAM.
Thank you, CEO James from the Quinus Technologies, giving us a great presentation about this innovative technology, ULTRARAM. Okay, so next, we would like to welcome the winning team from Israel, and which is under the categories of sport manufacturing. Their company name is Newsight Imaging, and it is a semiconductor startup with a goal of making 3D technology. So now, without further ado, please welcome the CTO and co-founder, Eyal Yatsken. 掌声欢迎。
Thank you so much. I appreciate the opportunity to present our company here and being selected. Newsight Imaging was established in 2016. We've been working on specifically 2 main markets. One is machine vision, and second one is spectral analysis. Our machine vision serves many type of applications. So if you talk about a camera of 3D, you can use it in virtual reality. You can use it as eyes for robots. You can use it in the automotive to guide the car how to drive and not get hit. And eventually LiDARs for the autonomous car. Smart city, open, closed doors, count people, many usages for 3D sensing. And even in a mobile phone can be integrated inside. Now, what's special about our products? We make our products combine high performance and low cost, which is not an easy task. We work with low power, very easily integrated. If anybody visited our booth, you could see the demo only connected with a simple USB cable to get the power and get the data. A very simple integration. And the very flexible design that enables us to customize the chip to different applications. We've already sold over 400,000 chips. It's a big number, but not big revenue yet, because chips are relatively low cost. So we still have a lot to grow. We still look for funding. We already got a lot of recognition. Besides in Taiwan, from the E-Time, we're selected and so on. A little bit about the technology. As I mentioned, our main focus now is the 3D sensing. We have two technologies, enhanced time of flight, which takes measurement of the time it takes to the light to go and come back from the object. A more geometrical way, a multi-triangulation, which is still the more selling product. We have spectral, and some companies use our chips just as very sensitive and quick solution. By the way, if you look at this 3D picture, you would see red pixels are close, blue pixels are far, yellow are in the middle. So it's kind of a color coding for 3D pictures. So by the color, you know the distance. We'll see it also in a clip later on. We have, of course, competition. There is indirect time of flight, direct time of flight, different technologies. We have our own patented technology, enhanced time of flight, in which we can give good resolution like the indirect time of flight, but distances almost like the direct time of flight. So we actually give the benefits of both other technologies that cannot give it together. We design chips, we sell chips, that's our main business, but we also can develop and sell modules. In terms of systems, we prefer to work with system houses that will buy our chips or modules and make their own systems. Still, we are making some prototypes, some demo systems, so we know how to make systems, but only for demonstration. We prefer system houses to do it more professionally than us. We are experts in chips. We've already developed several chips. You can see NSI 3000, the most selling part, which was simplest but most selling. We have NSI 1000, we have several chips. Important to note, NSI 5900 is a chip that was not unlike the others which were developed in Tower Semiconductor in Israel. NSI 5900 was developed with TSMC process, a very unique process with close cooperation with the R&D in Hsinchu. However, we didn't have the budget to finish it, and this is actually the chip that we bring here. We try to budget it. We already proved the technology with NSI 9000. We showed it in our booth that it's already working. But if we want to get supreme performance, we want to do this in TSMC with NSI 5900, and for that we are looking for a budget for the 10% missing in order to finish it. That's some details about the sensor. I will not go into technical details here. And this is about the simple integration of our chip, a simple cable of USB. You can operate it. So very, very simple way to work with our sensor. Thank you very much.
Thank you, Mr. Yasken, for giving us such wonderful presentation showcasing the 3D technology. Right, so next, we will have two winning teams under the categories of smart mobility. And the first one is the company GalaVerse from the US. And GalaVerse is able to boost the latest evolution of high-frequency radio technologies. So now, please welcome Professor Branka Vucetic, the Chief Scientist and Chairwoman Board and IEEE Fellow. 掌声欢迎。
Hello, everyone. My name is Branka Vucetic. I serve as Chief Scientist at GalaVerse. And also as University Professor at the University of Sydney. It is an honor to receive an IC Taiwan Grand Challenge Award in the Smart Mobility category. I'm delighted to attend this event with GalaVerse's CEO, Mr. Joseph Chue, who brings extensive experience in the telecommunications and semiconductor industries. GalaVerse, founded in 2022, is an US-Australian company specializing in developing cutting-edge chips for the telecommunications industry. GalaVerse is a company that has strong expertise in developing solutions for Wi-Fi, satellite communications, and for cellular mobile. We are extremely thrilled that our proposal for developing a cutting-edge chipset for integrating communication and sensing is one of the winners of this prestigious award. Our winning solution leverages advanced AI to process Wi-Fi signals, enabling simultaneous communications and measurements of human vital signs like heart and breath rate, and in a non-invasive wireless way. An essential example of technology's applications is remote healthcare, where it will enable continuous and non-invasive monitoring of patients at home, thus reducing hospital visits and early detecting of health issues. This is particularly important for the elderly and those suffering from chronic conditions. GalaVerse was established by a group of semiconductor experts from the US, Australia, and Taiwan. Today, its diverse team consists of telecommunications and semiconductor engineers, business professionals, and university researchers. Our team has a proven track record of developing world-class technologies in satellite communications, Wi-Fi, and 5G and beyond. The US is renowned for making innovations in satellite communications and cellular mobile networks and devices. Australia has made some groundbreaking contributions in Wi-Fi, and Taiwan is pivotal in the global semiconductor industry. Key common attributes of these three countries is their commitment to innovation-driven development. And this is a key value of our company too. We will remain firmly aligned with Taiwan in advancing technological and scientific progress. Lastly, we are grateful for the invitation to participate in the Taiwan Innotech Expo, and we want to extend our thanks to those who visited our booth, where we showcased our work and hosted a pitch and demo event. Thank you once again for this remarkable recognition, and we look forward to continuing our work, contributing to a smart mobility future, and strengthening this new partnership between Australia, the US, and Taiwan in the semiconductor industry. Thank you very much.
Thank you, Professor Vucetich, for this introduction for GalaVerse innovative technology. So now to follow, we have a team, Ranictek, which is from Taiwan. And Ranictek is an IC design company focusing on developing 5G and 6G base station chips and satellite communication chips. So now, please welcome CEO Mr. Wang Yifan to tell us more about it. 掌声欢迎。
Okay, hi everyone, and we are Ranictek, and I'm Mike Wang, the founder and the CEO of Ranictek. And we are IC design startup, and we try to provide energy saving and cost-effective base station and satellite communication chips. And we know currently the 5G deployment is slow because the traditional base stations are very expensive and be dominated by few vendors such as Nokia and Ericsson. So there is a new type of base station called Open RAN. The operator would like to have more vendors to choose to deploy the base station. Yeah. And the ORAN base station has 3 modules, RU, DU, and CU. And the RU also needs the chip solution, so we try to provide a chip for the RU modules. And each module can have multiple vendors to reduce the overall base station cost. In Taiwan, we also have many Open RAN vendors, but most of them are focused on the small cells. And the small cell can only be used for private network only. And also, we think Wi-Fi is much more cost-effective and maybe better than the small cells. So we focus on the ORAN, but we consider the macro and the micro base station rather than the small cells. And it can be used not only for private network, but also public network. And we also provide the baseband chips for the satellite, like LEO satellites or ground stations. And our core technology is mesh MIMO, which means the base station or satellites can use large numbers of antenna. And by our baseband solution, we can provide energy saving, larger coverage, and better performance. And as you can see, we can focus on the energy to the cell phone's directions. So for some place, if there are no cell phones, they may not have any energy loss. Yeah. And currently, we have our mesh MIMO FPGA solution, and we can support to 32 antennas and 64 antennas. Yeah, and focus on the FR1 band for 5G. And for the energy saving, we can provide about 30 to 60% power saving for each base station. And we may extend the battery life of cell phone also, and up to 2 times. And in Taiwan, we may provide about 1 billion degree power saving. We can provide energy saving because we can improve the SNR to about 9 to 11 dB, and we compare to the traditional 4G macro base station, which is up to only 8 antennas. And in Taiwan, we have about 2.6 billion power consumption of the all base stations in Taiwan per year. And so by taking 50% into account, we may provide about 1 billion degree power saving. And we also have the solution for satellites and ground stations. Yeah, and we have the digital beamforming structure, so we can have a better performance and more reliable service. And we have some patents, and I also have published some IEEE journal about mesh MIMO. And for the competition, Qualcomm solution is very expensive, and their solution is not fully ORAN. And the Picocom, MaxLinear, HQ, and Taiwan company called Yichuan, they provide chip solution for small cells. And different from them, we provide chip solution for macro and micro base stations, and with fully ORAN interface. And our target customers, of course, are the ORAN base station vendor and the satellite communication vendors worldwide. And we sell FPGA or chip to those vendors. And right now, we have obtained about 35% of our capital in revenue, and our YOY revenue is about 70% from last year to this year Q3. And for the market size, by 2030, the overall market size of ORAN base station and satellite communication is about $200 billion USD. And the US operator AT&T also has deployed the ORAN base station in the US. Yeah. And why Ranictek? We have some work experience in IC design, telecom operators, and also system manufacturers. And we have the know-how of mesh MIMO technology. And also we have some POC customer right now in Taiwan. And I have a PhD from National Taiwan University, and I have worked in IC design, MediaTek Group, telecom operator, Zhonghua Telecom, and some system manufacturers. And we founded in Taiwan, and we are an IC design startup and headquartered in Taiwan in November 2022, founded in 2022, and we have about 10 members. And we provide both FPGA and chip solution, and we are also doing $2 million USD fundraising. Yeah. And we have some POC customers in Taiwan, and we also have partnerships with Zhonghua Telecom, and Zhonghua Telecom is the tier 1 telecom operator in Taiwan. And we have some media reports, and we also obtained many international awards, like the IC Design Award at VivaTech this year. and also this competition also. And we also obtained many awards in Taiwan. And this is next week I will go to Florida in the U.S. Join the Plug and Play Explosion Day, and we will pitch our products too. So welcome to join us. And thank you. It's my contact information.
Thank you, Dr. Wong, for this captivating introduction. Thank you so much. Thank you. Right, ladies and gentlemen, to move on, we will have two winning teams under the categories of sustainability. So the first one is Polaris Electro-Optics from the US, and they are aiming at defining the standard of moving information. So now, without further ado, please welcome the CEO of Polaris Electro-Optics, Mr. Jason Stickler. 掌声欢迎。
Hi, everybody. I'm Jason Stickler. I'm the CEO of Polaris Electro-Optics. I want to tell you a little bit about what we're doing for next generation optical data transfer. That's, of course, for communications, but also more and more for computation. So really, today, computation, particularly in data centers, particularly for AI and machine learning applications, is limited by data transfer rates, your ability to move data within the data center. And so, not surprisingly, you can see that in the fact that hardware, on average, spends 70% of its time in the data center waiting for data to show up and doing nothing other than burning energy. And so, people have tried to address that, and we've been working hard over the last few years to keep increasing data rates, as is shown here. What's in volume here is at 50 in 2021, where it was first shown. It's now in volume. This next step here, though, has already started to need to move away from silicon photonics as it sits now. So silicon photonics are silicon chips made for light instead of electricity. And these are really the heart of how we do optical data transfer. But we're running into limitations on how fast it can transfer data. It's fundamental physics. And so the industry knows this. And so they're bringing new materials into what is otherwise the conventional silicon process to enable it to keep scaling. And that's really one of the things we bring to the table. And of course, I think our solution is the ideal solution for a couple of reasons. The first is we can integrate our material, it's a material that enables it, after the chips have been made and left the foundry. So you don't have to change how the chips are made today. Not all people in the space can say that, and that is hugely beneficial. Anyone who's been in the foundry world knows if you don't have to do process development, you'd rather not. And so that lets us move much more quickly. That also means you can make the chips anywhere that you can make silicon photonic chips. So that offers a lot of flexibility, of course, including here in Taiwan. The material itself, and I can touch on it a little later, is sort of a new material of an old type. It's a liquid crystal. We know how to make those. It's made with the normal stuff, with the normal processes, nothing new. You just need to know what to make. And so this was discovered at the University of Colorado in Boulder. And our patents, actually, I'll mention, cover it completely. So no one else can use this material without our patents. So we're in a strong position that way. And of course, at the end of the day, you put all this together, you want to show, and we've shown, and I'll show this coming up here, superior performance, you need to show reliability, and the fact that this is a class of materials, so we keep improving it. It's getting better, whereas other materials are defined, they stay where they are, they don't change. And so this lets us go out and augment and allow this scaling to happen for currently what is the silicon photonics market and what's called pluggables. These are these little matchstick things that get plugged in and have fibers coming off. That's the market today. We can enable that. But people talk about, in the data center, eventually replacing the copper with optics between memory and compute. That's going to come. Data center disaggregation, they call it. And that allows you to make the data center, ultimately, if you can go fast enough, be 2 to 4 times more efficient. I think even in the US alone, the electricity you could save is somewhere in the hundreds of billions of dollars of electricity annually. So it's a big number. It's a lot of impact at the system level. In that future platform, there are a lot of proposals on, here's how we'll do it. Here's how we'll do the optics of the future to do this. They all use silicon photonics. They're all going to want to keep increasing their speeds. And so we're going to be there to work with them, whoever wins that race, to enhance and allow them to continue scaling as well. A little bit here, I'm not going to get into this too much because it gets hairy, but the essence of this is what's called the modulator. It's like a shutter. The light goes through it, you open it, that's a 1, you close it, that's a 0. So if you can open and close it faster, you can pack more data into every second. That's really what it comes down to, and that's what the material allows. It's really that simple. I won't get into the rest of this. We've made our second generation of chips. This was our first high-speed designs. We've shown the easy integration done after the foundry. We've shown how inexpensive it can be. It's pretty negligible impact on the cost of the chips in total. And we've shown performance. So this is what everyone wants to look at for data. This is called an eye diagram. These black openings, the eyes, you want to see them open. That means you can tell whether it's a 0, a 1, a 2, or a 3. That's how it works today. And we just had this presented at ECOC last month, which is one of the big conferences in our industry, the post-deadline paper. And this is bleeding edge performance today, what's in volume. You can think toward that future that I was talking about of disaggregating the data center, and you can look at the other materials in the space that are vying for this. And when you put us up against them on the metrics that matter about being fast, being inexpensive, being small, and then being reliable, at the end of the day, when you look at performance and you look at manufacturability aspects, this is why we think we have a superior solution. So that's where I'm going to stop. That's the end of it. I want to thank you, the organizers of the event. Thank you for having us. We're really honored to have received this award and look forward to coming back to Taiwan a lot. Thank you, guys.
Thank you, Mr. Sickler, for this wonderful sharing of this innovative technology. Thank you so much. Now, to follow, we have our final team. It is called Voltraware Semiconductor Corporation from Taiwan. And it is a fabless semiconductor company specializing in the research and development of ICs. So now, without further ado, please welcome the Senior Director of Voltraware, Mr. 许志伟。掌声欢迎。
It's a great pleasure to be here today, and thank you for having Voltraware to participate in such a great event. So we are Voltraware, and this is the mission and vision of Voltraware. We very much like to use the technology that we developed for the wireless power and bring this technology to actually having people to enjoy the wireless freedom. So who we are a group of people who is specialized in the research and development, particularly for the IC and system design for the wireless charging systems. We were founded in 2019, and we are based in Taiwan. Currently, most of our people is related to research and development. So what's the expertise of Voltraware? We are, our technology is basically based on the magnetic resonance. It's a technology that brings the wireless charging very much different from the wireless charging that we see nowadays for our smartphones. The difference is that it doesn't require precise alignment between the transmitter and receiver. And also, it allows you to actually have a spatial freedom while getting charged continuously. We have been working with a international standard body called Airfield Alliance because we want to have our technologies becoming the standard so we can actually promote this technology and then having more people to adopt this technology. The first version of our IC solution, which is the VW8000, has been completed, and we have ever since then used that IC into very different applications. We provide one-stop wireless charging design solution, which means that cover from the very first beginning from ICs and then all the way down to mass production. So what's magnetic resonance? It's a complicated technology, but put that into simple words is that imagine if you want to hear the radio in your car and you try to use the little knob and tune that to a particular frequency that you want to listen to. The only difference is that when you are trying to make that into a product, it's much complicated than that. So what we are good at is by using IC solutions and design, we are able to make that complicated engineering process into a really simple design. So the difference between the MR system and the conventional wireless charging is that we operated at a 6.78 megahertz. That actually generates the minimum heat generations on the surrounding metal objects. We are able to provide a much longer charging distance, and as I mentioned before, it allows the device to be charged positional, more flexible on the charging pad. And the design for the coil size for transmitter and receiver is more flexible. So you can actually have different sizes for your transmitter and receiver coil sizes. The foreign object detection, it's a critical feature, particularly for detecting metal objects around the charging system. It's optional for us because we don't really generate much heat around the metal objects. In the past over a few years, we have developed our own design tools. We have tapped out the IC, and we also have developed several systems for robots, for e-micromobilities. Not because we are just trying to making demos, but really understanding the needs of our customers and solving the problems for them. The services that we provide are basically including from the very details of the engineering discipline all the way down to mass production. So control, system communication, protection circuit design, coil design, also including the safety and EMI, EMC certification, these kind of processes. And also we provide technical support for helping our customers when they are having some problems in mass production phase. So what's good about using this IC is actually making the mass production much more easier. We can also solve the problems of having customizable user charging behavior. It's integrated foreign object detection and protection functions, and it provides the designer or the user operators with real-time monitoring of the operation conditions. And of course, the very benefits of using IC is cut the cost and size of the overall systems. This is just one of the applications that we developed for our customers. And we actually have a PTU, which is the power transmitting unit, and the receiving unit embedded underneath the e-bike. So what you do is simply just, after finish your ride, simply just park your bike onto the charging pad and leave. So the charging process will just autonomously start charging your onboard batteries. In this demo here, we are actually providing 150 watts at output with a charging distance of 15 centimeters. And here are some other applications for, like some of the applications that I mentioned before for the AMR. So the advantages of using such a system including increase the utilization rate. It actually increases the battery life, reduce the cost for the operators, and it provides 24/7 automated operations. Because it doesn't have any contact point, so it provides a much more safe charging feature, and it's actually very advantageous in using this kind of system in dusty or chemical or moisture, this kind of harsh environments. And here are more applications for the wireless charging, so such as electric wheelchair, because some of the people who is using electric wheelchair, they are likely to unable to actually plug the charging cable for themselves. So it brings a lot of benefit for this kind of applications. So that's the end of it. And if I have missed anything or anything that I did not explain clearly, you are welcome to visit us at the booth FA06. There we can provide more details about our technologies. And thank you very much.
Thank you, Mr. Shi, for introducing the remarkable development. And that's all of our winner of IC Taiwan Grand Challenge this year. But before we conclude this event, may we invite Mr. Conrad Yang, the chief organizer of IC Taiwan Grand Challenge, to come onto stage and give us some closing remarks. 我们掌声欢迎杨光磊总召集人来为我们做闭幕的致辞。
Well, I don't know what you seen on the screen. I was very impressed with this final presentation because we went through a few months of evaluation. Honestly speaking, this is the best pitch than before. So congratulations, you guys make a lot of progress. I personally really enjoy it. I think this is a start. We are trying to using this event, challenge event, so that to be able to attract a lot of innovative company, especially related to IC-based innovation, to come to Taiwan to work with us, because Taiwan definitely has the world best IC infrastructure to be able to help anybody in the world. Taiwan is really a friendly country, friendly to everywhere. So we are very good in mass production. We might not very good in innovation. So hopefully we can work with anybody in the world who has a lot of innovative idea. We can help them to make a volume production. So I think it's a win-win situation. And hopefully, this is just a start. I see the bright future for many, many years to come. Anyway, that's all I need to know. Thank you very much, and thank the Vice Minister Su to give me this opportunity to organize this event. Really appreciate it.
Thank you, Mr. Yang, for this wonderful and inspiring closing remark. Thank you so much for your dedication. So, ladies and gentlemen, this is the end of our IC Taiwan Grand Challenge Unveil. Thank you so much for your participation. Can we have one more time a big round of applause to the winning teams? Congratulations. Well done. Thank you so much for your dedication. All right. So, in the end, we would also like to welcome everyone to visit your booth at FUTEX International Area. So, once again, hope you enjoyed the pitching today and wish everyone have a great day. Thank you.